So Brendan's going to be with us for Q&A, and he's pre-prepped some presentation for us.
But I created a full video.
You did.
All the talks I've heard today were live, but I was under the impression that sending in a video was also just fine. And I was a little nervous about my internet failing or something not working when I was trying to show live.
As you will see at the end of the day, I am the same way. I'm much happier having it done and locked down. So mine is also a video.
Oh, well, that looks wonderful. Thank you.
Yeah. So we're going to fire this off here, and then we will drill you with our questions after.
I'm Brendan Farrell from Clockwork Micro. Today I'm going to present our tool db2vector. It's a tool that abstracts a lot of the DevOps related to delivering vector tiles from a PostGIS database. So here's our title page. As I said, making production vector tiles simple with db2vector. So how do we visualize geospatial data that we have in a PostGIS database? Tiles, of course, have become very popular in the last handful of years, and as of recently, PostGIS has a function that allows you to create vector tiles directly from the database. So they're now easy to create in a sense, but if you want to make a web map, what else do you have to do? So you know how to do or create the query you'd like to create. You have the data you want. It may be a complicated query. That part you know how to do. What else is there to be done before you can have your web map? So that is a lot of what I'm going to discuss, and what this tool offers. It abstracts that so that you can focus on just the data or just the query you need to make. So here we have a simple display. The db2vector tool, it's a user interface, a text editor that allows you to write a query that has to be formatted in a special way. It's not pure SQL, but the core part is SQL, and it allows you to create an endpoint. So you can see in the picture on the left, we have some of the statements that are necessary. So st as mvt geom is creating the vector geometry, and that is part of the query. So you can see that's just a little extract, but you can see how we select the name of the polygon, the vector geometry, and the geometry includes this bounding box geometry. So what we'll see is you can write that type of query, and then we have a function that allows you to publish it, which is to create an endpoint, and then that endpoint has this format that allows you to just pass z, x, y to a URL to receive the appropriate vector tile. So that endpoint can be used in a web map, can be used in Leaflet or MapLibre, or you can use the tools that we offer to deliver the rest. So we'll discuss why that's helpful, what other pieces of the puzzle there are, but that in particular allows you to go from the SQL query to a simple line, a simple endpoint that you can enter into your web map to pull the appropriate tiles. Okay, let's see how it looks. So now I'm going to go into we call these tools map tools within Clockwork Micro, and then there are 3 to create a map, but of course we're focusing here on db2vector. Let's pull that up. I already have a handful of examples here that I've made, and today I'd like to discuss one in particular, or start with one, this large US counties. So suppose you have a database with all the United States counties. There are 3,000 of them, and let's just say you'd like to create a map that shows counties above a certain size. So that's what we've done here. It's a very simple example. but we'll see how it works. So the the statement has already been saved. It's already been created. The endpoint has also already been created. But let's open the editor to see it. So we can see here that we have our SQL query, and it's very simple. So the the bounding box and how that's formulated can be just copied. One doesn't have to understand that. One only has to work with this middle section here. So in particular, where are we pulling from? Bounding box remains the same. In our case, we have demo.counties underscore US, and then we run this intersection, and we have a where statement. So here we're requiring that the area is greater than 2,000 or 20,000 square kilometers. So here's what one would like to focus on if you're concerned, or you're focused on your data and the query, and you're working with your map, and you'd like to adjust, for example, this the size, whether it's 20,000, or you'd like to put a maximum condition or any other type of query parameters. That's where you can enter them, and that's where you can focus on it, and the rest makes that easy to do. So you can then preview your statement. You can reset to how it was, and you get to see it, executed right away. So clearly that's helpful, because when you're running these types of queries and you're tinkering with them, getting them right, you might have some mistakes. Here you have this editor, and you can see right away the result. You can also set minimum bounds, maximum bounds, the zoom. You set a default here so that you can really work on your query. Okay, so now let's see what happens when we create this. So I've already published it. I could do that again, but I don't need to. So this will publish and create a link. Let's go back and have a look. This was large US counties, and so it creates this dynamic tile endpoint. So we copy that endpoint and load it into our HTML for the map we're trying to make. So here you can see line 34 is where we've just copied in db2vector, and we pass it this zxy. So this is MapLibre here. So that is the simplest use of it. We have a map that we're creating, and instead of having the query here or the query run elsewhere and having a long query, we just are able to call one endpoint. This is created, we enter that into our map, and that gets implemented. So now we can go back and look at what that creates. So here is the map example db2vector that we just created. So it's using our base map and showing counties in the United States with an area greater than 20,000. So that is really the simplest example, or a very simple example. I'll go back and show just one more. If you are running a query such as, I'd like to show this one, such as showing the largest county in every state. Well, then often you're focused on the query and you'd still like to see it. If you're actually computing tiles, you'd like to make sure you're doing it right before you run through the whole United States and tile everything. You may have a process there. Here, it's all created on the fly, and you can make your adjustments very, very easily. So we have essentially the same format here, and here's where we focus on the query. So in this case, we have this simple where clause and a group by, where we take the largest polygon by area. And so that is then published, and again creates a vector tile endpoint. So um, that's the tool. The key thing is that it allows you to focus on the SQL query. I'll go back and just show very briefly that within map tools, after the vector tile endpoint has been created, you can style it. That's where you choose color and border and that type of thing. And then if you want to make the full web map, you can use our base map and put that layer on top of our or any other base map and create a dynamic web page. So, but here though, I'll focus on the db2vector. And I think that small example shows it. I can show one more where, again, you can see how a lot of the difficulties are abstracted away. So let's take a look at, we have another one here where we show airports in Japan. So this example, it creates rings or little polygons around the airports, but it has an intersection here. So we're intersecting a geometry table, I'm sorry, a countries table for Japan with an airports table. So if you want to make such a join between two tables and then get the output, or anything else that's complicated that takes into account several tables, other calculations, group bys, etc., you can write them here and see the result right away. Clearly, you can do that using other tools, but then once you get what you want, when you have the result you want, here you just publish it and create that vector tile endpoint. And then you just pass it the necessary variables. All right, so let's return to the slides and just discuss for a moment why this is useful. So here are some of the things that we abstract away. So the DB connections. The DB connections are created centrally. Then you have a list of connections. Those are all stored on AWS as secrets. If you're creating multiple web pages, multiple maps, you don't need you don't need to repeat such connections, but it also abstracts for you hosting or holding those connections so that they're kept in one place and secret and available for all the tools that you're building. Other small things, min and max zoom. So if you're making a web map and it's calling a Postgres database directly, if you do not set min and max zooms, you can unintentionally create too large a burden on the database. So these are important or even often necessary items to have. You don't have to code them yourself. You don't have to repeat them every time you make a web map. They're set. In fact, they're set by default to be fairly restrictive so that you do not create too great a load, and then you can adjust them. The tool runs many database connections. Usually when you're looking at a web map, there may be 30 tiles that are being queried, but with scrolling it can be even more. So there's some database connection management that we've started work on that. We manage them to a degree. We haven't yet worked out everything, but that's an area where we are handling it and improving it, how we close and clean up these connections. And so that is something that then the user doesn't have to deal with. As I said, the visualization, you can see it right away. You can change your query, see it immediately in the editor, and so that saves an enormous amount of time. The db2vector object can be used as a single endpoint. So here's meaning throughout an application or across a business. So we've worked on projects in the past where there are multiple maps and different layers appear in different versions of the map. And so if you have to repeat this code or copy it or keep them synchronized between maps that use the same layers, that can be a little tricky. This abstracts it, so you can make one layer. It could be, let's say in our case it was county outlines in that example. Then you can keep that layer as one object, and in one case you may style it one way. You could style that with us and save that style or elsewhere, but the point is it's abstracted away now. You have one object that's that layer, and you can use it across projects, across maps. As I said, we have a simple styler. You can style them there. You can use the map stacker to also to create the final web map. And then I'd like to say when this is good for use, or when this is appropriate to be used. And for that, I'll switch back to video. So we built this. We built this when we switched to using Postgres and the vector tiles on the fly, rather than computing them using Tippecanoe, and that was for flood maps in the United States that are updated almost daily. So in the United States, several counties have an update every day to their flood maps, and so it's too large a load to compute these tiles daily, if you were to truly compute them. And so we moved to on the fly and using Postgres and the vector tiles. And that was a very good case because the data set was so large, we could not do it. It did not make sense to do it using the hard compute. And we needed the updates to automatically propagate through our project. And so that was the motivating example for doing these. And we find that taking this approach makes sense when you have several scenarios. So one is large data sets or large databases. In particular, we used to do computations where we would run the entire computation. And now we do less of that. We do everything just locally and on the fly when a query comes. And so this approach is compatible with that. We used to make, for example, some materialized views, and now we do not. We just run the query and we create the tiles on demand when they're called by a browser. And so for large projects, there the min and max zoom are super helpful. Turning on and off layers is very helpful. A second area where this is useful is when you have constant updates. So if your data is being updated regularly, rather than hard computing, you just always do everything on the fly. And so this is a way to have the visual, the map display, also update immediately after you make a database update. So the area where this does not make sense, where this is not useful or optimal, is when you have a small data set. So if you have a very small data set, Postgres, delivering these tiles on the fly is smaller than if you have that data, available somewhere to be read and displayed. And so that's a case where this approach does not make sense. But other than that, if it's large, if it's updating, we have found this to be a very effective way to do things. So I will stop there, and I look forward to questions.
Okay, thank you very much, Brendan. And Brendan is here to answer your questions. Hey.
Hi.
So we've got questions from Damodara. Where do the vector tiles get stored? Well, I think you kind of answered that at the end of your talk. They aren't stored, are they?
No, they're not stored. They're all made always on the fly.
Yeah. Bruce Rindall asks, can you add other attributes to the MVT for CSS styling and info boxes?
As far as I know, not in the tiles themselves, but then we are building tools to allow you to style them or create that, but not in the tiles themselves.
And then Bruce has another question which sort of feeds into the first one, which is, can you cache layers or do you need an intermediate API for that?
The caching is a little interesting. So we do not currently cache at all. I believe you certainly could cache, and you could do that in several different ways. But we do not. One could. And in particular, we do everything on AWS, and there I think you could set up like CloudWatch to cache, but we do not do that yet.
Yeah. So how does this differ from, or maybe it doesn't differ from PG TileServe, or we saw TiMVT. Martin is sort of the granddaddy of them all, but it seems like a very similar setup to PostGIS-driven tile generators.
I mean, I have to confess to not having used the Postgres tile generators, but everything is all built on Amazon. It's all, it's a bunch of Lambda functions essentially. So the coordination or the infrastructure is now done, say, on using Lambda functions rather than in a server that one is operating. So I believe that'd be one difference. Other than that, I really can't say how it differs.
Okay. Do you have any issues with connection pooling or use of connections and Lambda functions?
I mean, some. So we've had some difficulties, and we've smoothed out some things. So we've been going about it. It's still fairly new, so our understanding of exactly how you can handle connections that are no longer active when you have requests where the browser is no longer waiting for that tile, and you've got old requests. So those are still things that we're working on and figuring out. And yeah, so there's definitely a lot to be done there.
When did you start getting into using PostGIS?
When did I start using PostGIS?
Yeah.
Oh, I don't know, but I would like to say I learned from Regina Obi's book about 5, 6, 7 years ago. That was the first book, and then Elizabeth was talking to me about the schedule today when I spoke with her, and she said her name, and I remember, was she the woman in Boston who wrote the Postgres book? But that is how I learned a while back.
Nice. Let's see, do we have any other questions? I don't know that we do. So great.
Okay.
Yeah. There's a question, can we generate the tiles in a directory?
Yeah, there's so much more to be done. So, this is kind of V0 that we've put together, creating tiles and spitting them out to a directory. That's also something we'd like to look into.
All right. Thank you very much for your time and for coming to talk with us.
Yeah, thank you. Thank you very much.